Okay, so the next video here is relay ladder logic, and we're going to talk through how we develop and lay out the schematics to describe the functionality that we want to have for the control systems that we're dealing with. And so again, this is going to be where we have the inputs connected to the outputs in a certain way to get the outputs to turn on in a certain time. And there's some rules that we want to follow when we do this. So this is a typical relay ladder logic layout, schematic wise. We've seen the transformers before, right? So we have our transformer, and this is stepping down 480 volts to 120. Okay, so again, a lot of times a control circuit, this is the control circuit. Is at a lower voltage than my power circuit, maybe the 480. I'm running my motors at 480 because I can get more efficient three-phase motors at a higher power. So I have my control circuit at 120. Of course, I have my fuses, which we've talked about when we talk about transformers. I have L1, L2, I have a ground point, and so I have 0 volts, and I have 120 volts. And then I start having my rail. So this is my bus. These are my buses. This is the 120 bus. This is the 0 volts bus. Basically a 120 volt power, 0 volt power, okay? And then I have my rails or rungs. Buses and rails kind of the same, but then rungs are what we have going between the buses or the rails. So this is the relay ladder. So that's why we have the ladder. It looks like a ladder. Okay, a couple things to note. I will have my rails numbered. So I will have at some point on here, let me kind of get some space here, 120. We'll do, let's be my rail 1, 2, 3, 4. And so I'll put in red the things that you would want to have actually denoted on your diagram. So you want to have all the black that we have here, okay? But then when you start adding some labels in addition to what I see here, we want to number our rails. We also want to do things like, here is my control relay, and there is CR1. That's very important. I've labeled CR1 with a specific tag because I have some contacts here and here that are part of that control relay. So they're part of that same relay. So when I energize that relay, those contacts are going to close or open. Okay, and so the way I just determine or depict that they are the same thing, physical thing together, is with the CR1. CR1, CR1. That says that when I energize the CR1 coil, the CR1 contacts will change state. One thing that's helpful to do is when I have the coil, I will tell on that, the other end here, I'll say on rung 3, I have a normally open, and on rung 4, I have a normally closed. The underline means it's normally closed. The non-underline means it's normally open, but I know now I can go to rungs 3 and 4 to find the corresponding contacts with that coil or for that coil. When I'm at those relay contacts on 3 and 4, I will give a return label or numbering rung. So I know that if I'm at rung 3, I need to go back to rung 2 to figure out when does that coil close. If I'm not sure when the contact of CR1 is going to change state, I need to look at rung 2 to determine when is it going to change state. Well, it's going to change state when my low pressure set point is reached. So if I have a pressure lower than 15 psi, I'm going to close that switch, energize CR1, and it's going to change the state of CR1 on rung 3 and rung 4, and it's going to affect my green and my red lights. Okay. So one other thing that we would see here, we wouldn't label with words. We would maybe say pressure 1, and LT1, LT2, and a lot of times you'll see a letter on the inside of the light as opposed to words above it. So the G denoting it's a green, R red, A for amber, B for blue, so on. Okay, so these are some other things that I would add and I would ask us to add. So these are things that we want to be including in our diagram. When we say a clear, organized diagram, we want to be adding the rung numberings, the device labels on all the devices. The next thing we want to do is whenever we have our inputs, we always put our inputs on the left side. Okay, left to right. So inputs go on the left side, outputs on the right side. Okay, I can have multiple inputs in a row, but I keep them towards the left. I have one output per rung. I keep that on the right. So this is a very important that's a super important thing. You're not allowed to have more than one output per rung in series. Okay, you can have multiple inputs on one rung in series, okay? Because you can have close switch 1 and close switch 2 and close switch 3 to then turn on something, right? We can do that, we will do that. But when we talk about outputs, we can only have one output per rung, okay, in series. We also want to be looking at, we have a 0 volts here, so we ground it, that makes 0 volts. The other one is high, or I don't know, 120, depending on our voltage, right? That's our high voltage. And of course, we were going to add our numberings, right? If we wanted to add or turn two outputs on together, so we wanted to say, when they hit the low pressure, turn on control relay 1 and turn on an amber light saying there's an issue, right? Or do something else, right? So I could have a second thing, a second output, if I want it to come on with CR1 together. You don't put it in series, but you can put it in parallel. So we can put outputs in parallel. So outputs in parallel will come on together. And we can do this, right? If I said, I don't want to have to use this rung 3, again, this is, right, the reason why we have rung numbers, so we can start talking about and all know where we're looking. This is redundant. When I energize CR1 and close CR1 contact on rung 3, it's going to turn on the green. Well, I don't want an amber. I just want the green light to come on when the relay 1 is on. So just get rid of all of this, put it in parallel with CR1, and now the green light is on when CR1 is energized, just like before. But I put it in parallel so it happens together. Those two outputs energize at the same time. The red still comes on whenever CR1 is not energized, right? We need that on its own rung, and which is helpful, right? Because we want to have that opposite function of the green light to the red light. So we want the red light on when the green light is off. Okay, so we can do this also. This is a parallel type of wiring of our outputs, and that's very common. We'll put things in parallel when we want to have them come on together for our outputs. Okay. The last thing we want to talk about is how we interpret the current flow. And so that's a really important concept to understand when we look at how does this circuit function. And so if I'm envisioning current flowing, when I close something, it will flow through that. So currently as it is now, current can flow through CR1 to the red and back to ground or neutral, right? And that red light will be on, okay? Once I close the low pressure switch, current will now flow through that to the CR1 and back to neutral. It will also flow through the green light. CR1 will open, right? And I'll have something like this. So current will be flowing this way. So CR1 will be energized, the green light will be on. That's how the functionality of that circuit will work, right? So it's really important, follow the current. When you're looking at how the functional operation of a relay ladder logic circuit is going to operate, we have to follow current. We have to pretend like we're current, pretend like we're the ants walking along the path, and when there's a closed switch, we can go through that, across that bridge, and go to the next thing, right? If there's an open, if the drawbridge is up, or there's a branch or a log in the path, we have to stop, right? So that's how we can interpret how the functionality of these circuits works. Another thing we want to be considering is when we draw these out, we want to keep them organized and kind of put things like we talked about, inputs on the left, outputs on the right, but give it some organization so it's easy to understand. This is a little tricky to understand what's going to turn on when and how, and especially there's no labels, right? So I have no idea what is this relay CR1, CR2. I have no idea, right? When is that going to close? Also, another thing to kind of be aware of, I have a common point, not common as in zero, but a same connection across all of these wire 25. So wire 25 connects to all of these things, these devices, right? And so that's a similar point on all of those. They're all connected to line 25 or wire 25. The other sides of those components are somewhere else, right? Go somewhere else, but at least that's a common point. And so we would love to wire these more in a grid pattern, okay? So we want them to be wired more in a matrix style, organized style pattern with rows and columns. And let's see here. Yeah, I'll do this on the side here. So let's start by looking at how would we redraw this? Well, we take all the inputs and put them on our left. So let's take, and we're going to start labeling this PB1, SW1, LT1, CR1, CR1, resistor 1. Okay, now that we have things labeled, let's start putting them on our diagram. So I have switch 1, I have PB1, and I have check CR1 normally open, CR1 normally closed, check, and the rest are output. So the rest are coming off of some of these switches. But let's remember that one side of all of those, switch 1, PB1, CR1, CR2, are all connected. Okay, that node connection. That's all line 25. So they're all connected to each other. Then I go to my R1. I can decide how I want to interconnect these. I can come off of any of these here. I also go to LT1. Okay. Bingo, and that's it. Okay. Yep, I have all my components, right? And so now I don't know the other sides, the total lefts and the total right sides of these components, but I do know in between, and I put them more in a grid pattern, and this is rung 1, 2, 3, 4, and so I can understand that R1 and LT1 are in parallel, along with SW1, PB1, CR1, CR2 are all in parallel to each other, right? So now I have some more organization. I can interpret it better. This is how we want to do it. No, yes. So again, full picture, we have rungs, we have labels, simplified labels. We would move, this would be green, LT1, red, LT2. This would be 3, 4, okay, and this would be rung 2 is where that coil is energized. And we would have our inputs on the left, outputs on the right, organized, kind of a row column setup, and much easier to interpret. Add that to where the slide was. We did that already.